Now this question is related to concept of racemic mixture. So this says optically active 2-iodobutane. So we have 2-iodobutane, and that is optically active. So you first write on the structure of 2-iodobutane. Many times I have said you must know how to write on the structure, optically active. So you will be given name and you have to translate this into a structure. So 2-iodobutane, you have 1, 2, 3, 4 carbon, and position number 2 you have a iodine group. So this carbon will be chiral because this side you have hydrogen, methyl and ET group. So you will have this, I can write something like this side I have a methyl, this side I have ethyl group, this side hydrogen, and this side iodine. So this is optically active. So question says optically active 2-iodobutane on treatment with NaI. So if I treat this compound with NaI, iodine is here, methyl is here, and if I treat this compound with NaI and in acetone, let me see, in acetone, yeah. So solvent is acetone, CH3COCH3 is a acetone, and this is acting as a solvent. So if I treat this compound with NaI in the presence of solvent, after some time it shows, which does not show optical activity. So this mixture that is formed, so solution does not show optical activity. Solution does not show optical activity. So what is the reason? You know the answer. So initially this is optically active. So let me see, you have taken one isomer, either R or S, and the finally solution become optically inactive. How this is possible? Can you tell me what is the reason? Yeah, you are right. So what will happen in this case? You have this CMe, and here you start H hydrogen, and now you have iodine. So what will happen if this bond breaks? You will get a carbocation Me, and this side you have carbon, this side you have ethyl hydrogen. Now you will have a carbocation that is a sp2 hybridized, and now sodium iodide I minus can attack from top, or I minus can attack from bottom. Are you getting or not? So if it attacks from top, you will get one isomer, let us call it R, and if it attacks from bottom, you will get another isomer, S. And that's why the optical activity slows down, and at in there is no optical activity, because what is happening? This can be in equilibrium. This is a equilibrium, is a equilibrium with this carbocation, and if this carbocation is formed, then it can be attacked by I minus. Now you see, this kind of experiment has also been done in the presence of radioactive iodine. So question is, if I take a radioactive iodine, initially there is no radioactive iodine, but after some time the product that will be formed will contain radioactive iodine, because iodine is attacking that is coming from NaI. Are you getting or not? So if I take a radioactive iodine, so let us say if I take a radioactive iodine, so in this case the attacking iodine that is radioactive, so I can say the product I will get that will contain radioactive iodine. So I will have CH3 Me this side, Et hydrogen, and I that is radioactive. So another product I will have Et Me hydrogen, and I star that is radioactive. So I will get racemic mixture, and this racemic mixture will make solution optically inactive. So this is a racemic mixture, and this will make the solution optically inactive because you will have 50% of R and you will have 50% of S. So this is 50-50%. So solution will be optically inactive, no optical rotation. So no optical rotation. And this optical rotation will slows down. Initially you will have some optical rotation. So this molecule is chiral, so it will have some optical rotation. But after some time, this, let us say this R, then slowly S will be formed. So optical rotation of S and R will be cancelled to each other. So optical rotation will slow down with time. It will take some time when optical activity goes to zero. Are you getting or not? So it will take some time. Basically, kinetics of this reaction can also be studied. What is the rate of loss of optical rotation and what is the rate by which this is formed? So there is a relationship between loss of optical rotation, rate of loss of optical rotation, and rate of formation of this compound or rate of loss of this compound. Are you getting or not? So what I can do, so let us call this compound as A. So we can measure the rate of loss of A and rate of racemization, that is the loss of optical rotation, and rate of loss of optical rotation. Are you getting or not? So rate of loss of A, so rate of decomposition of A, and rate of loss of optical rotation, that is the racemization. So you can say dA by dt, so rate of loss of A, that is dA by dt, and we can relate with rate of loss of optical rotation, that is the rate of racemization. So I can say dA by dt racemization. So we can basically relate these two rates, rate of racemization and rate of loss of rate of decomposition of A. And this relation has been basically studied. So in experiment, I exactly does not remember. So there is a relation either 2 times. So rate of loss of A is 2 times rate of racemization. Are you getting or not? We'll discuss sometime this problem also. Let us go for the next problem.